Hi guys, welcome back to another video. So I hope that you do understand the cast diagram as grade 12 learners. So we just have to jump into the question, right? So today we are going to check the trigonometry ratio and see how we can be able to tackle it, right? So the first thing that I'm gonna do is to write the question down. So now we are going to simplify this based on the cast diagram, which is very straightforward. So let's try to look at the equation, right? So we have the cos of 90 degrees plus theta, and we know that this particular cos should change into sine, and that will definitely be a good thing because we already have a sine negative theta here, so we can be able to deal with it. And as you can see that 90 degrees cos 90 degrees plus will change into a negative sign, right? And remember, we are talking about cos being at this point, right? So let's write our equation again and say that this is equal to 1 minus sine of negative this guy, and then the negative of sine theta, and then all over the cos theta minus 360. And cos theta, here we are at 360 minus, and this one will be negative 360. So this one is actually different from this guy here, meaning that although we know that we can add, for example, the plus of 360, so this and this will give us cos theta. So remember that if this is cos the cos at 360, then this guy does not change. And also if this is actually at 180, the cos does not change. It only changes when we have anything that has to do with the 90 degrees, right? Anything that has to do with 90 degrees. And then now we are going to say that this is equals to, right? So I'm going to multiply this particular sign and the other sign and see if I'll be able to do what to get my answer. And also if you check this point, you can simplify this point before multiplying them, right? So minus 1 is equals this is actually minus 1, 1 minus sine of negative angle, and this will definitely lie among 360, and it does not change. It will definitely be the sine of theta, the sine of theta. And then with that, it means that it's actually at the negative point. I hope that as grade 12 learners, you do understand the cast diagram, right? And then here I will write my negative sine theta again, and then the multiplication of the two will give us positive, right? Let me write cos theta, and then this is equals to 1 minus sine of sine square theta all over the cos of theta, right? So remember, this time this will give, this is just like x times x, which will give you x squared. So you don't have to be confused by that, right? So the best thing about this is that they've already given you the formulas, right? And then within the formulas, you can go there and try to see if you can be able to convert this guy so that you can actually simplify it further. So you see that 1 minus 2 sine square a is equal to cos 2 theta, right? So you have to think about how you can be able to deal with it, right? So now I think that we can look at maybe another one, if there is another one. There is this one that says 2 cos squared of theta minus 1. Is it equivalent to anything? No, right? So this means that you just have to make sure that you keep looking, right? So this means that if we cannot find anything from the double angle identities, you can try the cos squared of theta plus sine squared of theta, which is equals to 1, and substitute it here, right? So that's why we do have this one, so we can try it. So that will be, let me change the color. I don't have enough space, however this will be cos squared of theta, the plus of sine squared theta minus sine squared theta, and we now know that this one will cancel the other one, which is good for us, and then we'll be left with cos squared theta divided by cos square, and that will definitely be equal to cos theta. So the final answer for this will definitely be cos theta. Let me erase this part so that I can be able to write the answer, although you do know the answer now. So this means that after cancelling everything, this will be equals to cos squared theta all over cos theta, and then this will be cancelled, and then you will be left with the cos of theta. So these are the double angle identities. So in order for you to apply this, you know that you did learn about this in grade 11, and you should know and keep it in your mind, because if you can't find it in your formulas, it means that you'll be stuck here if you don't know how to convert this one into this. And also sometimes you'll find out that you're given a tan, maybe tan squared theta, so this is equals to the sine square theta all over the cos squared theta. So you have to know them by heart so that you can be able to solve these questions easily. So that's it for this question. We can move to another question. So I've already written the question down. This is actually the simplest question, right? Maybe they can actually give you like 5 marks for it as well. However, I just want to show you how fast or quick you can be able to approach it, right? So let's start with cos negative theta, which lies between this area, which means it's positive in a way. So it means that this will definitely be cos theta, and then cos 90. When you see 90, you already know that this is going to change, and 90, as you can see that everything will definitely change, and this will change into a negative sine theta, and then the tan of theta at 180 will now give us a tan, right? Because we are talking about this area. Even if we can actually change this into, for example, 180 plus theta, if you want to interchange them, you will definitely get tan theta as your answer, and then all over the tan of 360, the tan of 360 minus will give us a negative, because here tan is negative. We are at actually a cos area, so this will be tan theta. And then after that, we now know that we are dealing with cos theta, so we can just leave it as cos theta, and then the sine of 360 plus, meaning that the sine of 360 plus will give us a sine theta, as it is. Sine of 360 plus will give us sine theta. And then remember, now we can be able to check the division, right? This one, the tan will cancel tan, sine will cancel sine, cos will cancel cos, so everything will be cancelled, and we only have two negatives, right? Negative here and negative here, so negative divided by negative will give us positive, so this will be positive 1. Okay, so another thing is that I will have two videos at the end of this session. So if you started watching the exam preparations, by using this video, please go back and watch the introduction on how we can be able to alter the cos 90 degrees plus into the sine, and then why the cos negative theta is not changing, and so forth. So you can go and do that, because in grade 12 they do expect you to know the cast diagram by heart, and how the angles will cause the tan, the sin, and also the cos to change at 90 degrees angle. So now I'll continue to another question. So I'm going to start with 5.4.2 because this looks difficult for no reason, right? So here I will just move from this page to another page where I can be able to write everything clearly. So the first thing that I'm going to do is to maybe use these formulas to convert cos 2x into something here, and also sine 2x into this, right? Because the reason why I'm trying to do this is to make sure that the negative cos 2 squared is eliminated. So the one that can eliminate this guy will definitely be this one, right? So I'm going to change cos 2. Let me write it while we are here, right? So I'll change this guy, which is cos 2. So that will be cos 2x, which is equivalent to the cos of this, let's say theta or x. So you have to follow the standards. X minus sine x squared x, and then we now know that if we change that to this and substitute here, we are going to have something like this, right? We're going to have this, then the plus of sine 2x minus cos 2x, and then we are going to divide everything by this, right, which is negative 3 sine squared x, and then sine x cos x, right? And then since we are here, we can be able to see that the 2 will be eliminated, right? So after doing that, I will now move to the next step, right? So now on top we have sine, what is it? We have negative sine squared x, and also we have to change this, remember. So let me try to do that. So we're gonna have negative sine squared x, and then we are changing this guy into this guy just to make sure that we don't have 2x as our angle. So I'm going to have the plus of 2, the sine of x, the cos of x as it is, and then this is what we have. And at the moment, since you can see that we cannot convert anything anymore, we have to look for a common factor, which is sine x. But the thing is that this will be determined by what we get down here. If we get, you know, maybe sine squared x, we'll know that we're gonna take the sine x out and then cancel the one that is actually down there, or divide it by the one that we get down here. But now let's focus on the ones that we have down here as well, right? So let me rewrite this by, you know, writing. Okay, let me just divide it first by the 3, which is negative 3 sine squared x, and here we can also take out something, you see. So why not and that something will definitely be the sine. So I think we should actually do it before maybe moving to our next step. And if we do that, we can have this is it negative, or maybe 3 in general. But if it's negative 3 or something like that, we'll have to change this into a negative. But let me try to take out the sine first. So that will be sine what? Sine x into so I'm taking sine only, negative 3, the plus of 6 cos x, right? So if you check here, you will see that you can also take you can also, and this one here was supposed to be a sine. I'm sorry, this one was supposed to be a sine, isn't it? Because of the square. So 3, the sine, let me erase the board for that to take place. My apologies for that part. So we're supposed to say negative 3 sine, because we are left with the sine after taking out the common factor, right? So after that, we can say equals to, right? So here we can take the number out, and that number will be negative 3 out, and then here we're going to also take a number, and we're gonna be left with 2, so that when we multiply them both, we're gonna get a positive 6. So what can be that? So that will be as follows, right? So I'm going to write everything down here and say negative sine squared x, the plus of 2, the sine of x, the cos of x, and I'm taking everything out here, and then that means that I'm going to get the following, right? So I just want to also underline this part and try to revert back to that column. This will be negative 3 sine x, right, into negative out, and then that we're going to have sine x, and then this, for it to be positive, we have to make it negative 2, so that when we multiply it will be positive 6, and then we have cos x, right? So now we are here, and also if we check here, you'll see that we can be able to take the common factor of sine x, right? So let's try to erase the board so that we can be able to accommodate that part as well, right? So that we can be able to accommodate that part as well. So in order for us to accommodate that part, I'm going to remove the questions up there, and then I will maybe continue with the equation, and then let me take out. So if you check here, we have negative 2 something. We don't really care about that, although it's here. And it will definitely be, similar to this after taking out the sine x. So let me go back and write it. Here we have what? We have sine x. I don't like how this looks. So we have what? Negative sine. Let's take it as a negative, and then into sine x, and then in order for this to be positive, this will be negative, and then 2 the cos of x, right? So we took this out, and then we left with the following. So everything divided by this, and if you check, you'll see that this is negative 3 sine x into sine x minus 2 the cos of x. So this looks good, so if you see something like this, you know that this looks very good. This will cancel this, and then sine x divided by sine x, this will cancel this as well, and then we're going to be left with positive 1 all over 3. So this is actually the answer for this particular question. So you just have to make sure that you convert this guy, as well, and then after that you just look for the common factors. I feel like this is very important when you are dealing with these type of questions. Okay, so again we have the 5.4.1 that says that prove the above identity, and they say that everything here as given is equal to negative sine x, and remember this one here is different compared to this, so we have to make sure that we eliminate everything up until we get the solution, right? Okay, again I'm going to start by changing everything here, and then I will continue with everything down below. Okay, so let's see how we can be able to do that. So the first thing, as I said, that I'm going to change this part, and then that will cos 2x. That will be now that will be cos squared x minus sine squared x, and then after that I'll place this guy, which is 2x here, and then that will be plus 2 sine x cos x, and then minus cos squared, is it squared? Yes, x, right? And as I said that I'm going to deal with the one that we have up here, and then after that I'll deal with the one as the division, right? Let me change the color so that we can see. So now I'm going to say that the negative cos squared x will definitely be eliminated, and then I'll be left with this part here, and then I'm going to write it down here and say negative sine squared x plus 2 sine x cos x, and then all over sine x minus 2 cos x. We are looking for negative sine x as our answer. So again, I'm going to take the common factor. Remember what we did previously. We've taken out the common factor. So this one will be our common factor again, negative sine x into, right, sine x, and then the plus 2 cos x. You remember this part. But now for this part to be positive, when we multiply, this will be negative, so we have to make sure that this part is negative, because when we multiply back by negative sign, this should be positive. Remember last time what we did. And then now I'm going to do what? To divide everything by the sine x minus 2 cos x. So if you check here, you'll be able to see that we are now done with our question. So this will eliminate this, and then the answer here will be negative sine x. So the only thing that we were trying to do is to prove that this above identity, or this left hand side is equal to the right hand side. So we're done, meaning that we're gonna get our 3 marks. Okay, so now we are going to look at 5.5.1. okay, so they're saying that without using a calculator, show that sine 4x is equal to negative 0.5, right? It's actually the only solution for the above. So let's go and try this particular question and see how we can be able to solve it. Okay, so we have 3 tan 4x, which is equal to negative 2 cos 4x, right? So then we have to prove that this is equal to a half or negative half. So let's try to simplify it, right? So what I'm gonna do is that I'm going to start by taking this guy to the other side, because now we are solving this as if we are solving for x, right? So 3 the tan of 4x, the plus of 2 cos 4x will be our maybe first point, right? Which is equals to, what can we change here? The first thing that we're gonna change will be tan, and tan can be equals to the sine of 4x all over cos 4x, right? And then this will be the plus of 2 cos 4x, right? So sometimes when you see things like this, you can cross multiply, right? Because we don't have a factor. 3 and 2 not a factor, and also the sine cos whatever not a factor. So let's try to cross multiply this by the cos for there, cos this will be cos 4x, right? Multiply it by that, cancel here, this will be equals to 3, then the sine of 4x, the plus of 2 cos squared 4x, same angle, right? Still we are in the right direction. So we are treating this as like solving for x and y, right? So if we were to say let sine 4x to equal y, then what about the cos squared? So you cannot solve for x and y in one equation easily without any other equation to integrate it with, right? That means that you have to make sure that the sine and also the cos here are actually maybe equivalent or equals to each other. Like you should be able to deal with cos only or the sine only. And how can you be able to do that given that the equation looks like this? So remember, this is cos squared 4x. This is just an angle. We don't care much about it. So how can we convert sine 4x? We cannot. What about this one? Cos squared might actually be equivalent to something like this. Cos squared x, the plus of sine squared x is equals to 1. And then that means that cos squared x is equals to 1 minus sine squared x. Remember this, right? Simple as A, B, C, D. So this means that we can say equals to 3 sine 4x and then the plus of 2 into 1 minus sine squared x, right? Now, minus this with the 4x, right? So now we can see that we are actually in the right direction. We can come down here and say 3 the sine of 4x, and then we're multiplying inside. We are getting the plus of 2 minus 2 sine squared x. 4x, you know. So now we're actually in a good direction, because we can let our sine 4x to equal y and try to solve for y. What about that, you know? So I'm going to erase everything that we saw that we can have some space. However, I don't have to erase the other part just to be able to deal with this remaining area here. So I'm going to let my sine 4x to equal y, and then we're going to have 3y, the plus of 2 minus y, 2y squared, which is equals to maybe 0. Everything here equals to 0, remember, right? So now, since I have this, I can come here and say this will definitely be as follows, right? Let's see how we can deal with this. So negative 2y squared, and then the plus of 3y, then the plus of 2 is equal to 0. Multiply everything by negative, we're gonna have 2y squared, and then minus 3y plus 2 is equals to 0, right? We are continuing with our solution, and then now let's solve for maybe y, which is equals to 0, right? So now we are looking for the factors. Another thing is that we are already given that this the sine for whatever will give us a half of something. So I'm expecting even a half in the brackets, but let's see how we can be able to deal with it, right? So the common factors of 2 will be 1 and 2, and then this one will be 2y, and then with the y, this times this will give us y squared, this times this will give us 2. And then now we know that we have to cross multiply, right? So the cross multiplication of this and this will give us 4, and then this and this will give us 4, this and this will give us a 1. So if that's the case, it will mean that 4, this one 4y, and then the plus of 1. So we have to make sure that one is actually negative here, so that when we multiply them, we should be able to get our -3. So let's make this one to be negative and start again, right? So then this, let me change the color. This times this will definitely give us -4y, and then this times this will give us plus y, and then this will give us -3y, and then these are our common factors. So I'll come here and say we have our 2y, plus 1, and then we have our y minus 2, right? So since we dealt with that part, I hope that you do understand how you can use a quadratic formula if you want, but I was just using what I know and what you should use in the future, just to be quick with this, right? So now we can go and say this part is equivalent to the sine of x, 4x, and then plus 1, and then the other one will be sine 4x minus 2, which is equals to 0. And then we take out everything, we're gonna have sine 4x, which is equals to -1/2, and then the other one will be the sine 4x, which is equals to 2, right? So we're not really certain if this is equals to 2. However, this might not equal 2. We were just looking for this particular answer as given by our equation of the question. So we now know that our sine 4x is equals to -1/2, and this is what we were looking for. I hope that you do understand the approach and you are going to use it in the exam. So let's look at this question, right? So we are given a diagram as follows, right? Where we know that we have the positive x-axis in the R point, and also we are given the POR as the theta angle, right? So they say calculate without using a calculator, meaning that you can be able to do that given the question, right? So I'm using this part just to ensure that we do have our values, and then that will be from here to here will be theta, and then point O. So remember the P coordinate will give us negative, this point here will be -7 x-axis, and then this point here will definitely be what? 4, right? So we already have the 4 for the y-axis, which is good. And then they tell you that determine the length of OP, right? So then you have to come here and say OP is equals to the length of OP is equals to O to P. So we have 0, 0 by the center. And remember that you'll be given the formula, right? So with that formula, we can come down here and say OP will give us what? X2 minus X1. That will be, let's say, negative 7 minus 0 squared, the plus of 4 minus 0 squared, which is equals to 7 squared, the plus of 4 squared. This might actually be, is it 49 plus 16, and then 1 will give us 50, then 15 will be remaining, and then this will be the square root of 65, right? So now we do have the square root of 65 as the length of OP, and this will be given by square root of 65 as the hypotenuse side, right? So okay, let's move to the second question. And the second question says that give us the value of tan theta, right? So in order for me to get the value of tan theta, I can say that tan theta is equals to, remember tan theta, this is actually the sine of x all over the cos of x, and also this can be our y all over x, this being the opposite, this being the adjacent, and then now we should be able to check the opposite, which is this one. This is our opposite side, 4 all over the adjacent, which is our x, then we know it's negative 7, and then that's our answer for this question, right? And then again, we also need something else for 2 marks, right? We also need something else for 2 marks, and as you can check, the cos theta minus 180, right? So this can be something like cos theta minus maybe 180. We are allowed to add 360 to it, and then this will be cos of theta, the plus of 180, and we can now say this is just cos 180, then the plus of theta, and then we'll see that that will be at this point because we're allowed to work with a positive sign interchangeably, and then this will definitely, this will not change, but it will give us the cos of theta as negative because we are actually at the third quadrant, and then this is what we have at the moment. And then we go back and say, what is cos theta? You know, what is our negative cos theta here, more especially with the values? So we can now say that this is equivalent to let's say negative of what? Remember, the cos will take x adjacent all over the hypotenuse, and then with that we are going to get the following, right? Following answer, right? Negative into, what is our x? Negative 7 all over r, which is the square root of 6/5, right? And then with that, it means that the negative times negative will be positive, meaning that the answer here will be 7 all over the square root of 6/5. Done. So that's how we can be able to answer that question, and I hope that you do understand it and you are good with it. Okay, I'm going to erase the board and continue with 5.2. So now I've written the question down. Determine the general solution of this equation, given that at the end of the solution you'll get 7 marks, which is good. So I'm going to start with the question down here and continue with everything, right? So now let's take this to the other side just for 1 point. Sine x cos x, the plus of sine x minus 3 cos squared x minus 3 cos x equals to 0, right? So that will be equals to 0. And now I'm going to look at anything that I'm going to change. So it seems like I cannot change anything here. So I'll just have to look for common factor. It's either you change, and then if you can't change, then look for a common factor. I will take sine. I cannot take sine. So let me say sine x into the cos x plus 1. And then here, what can I take? I can take maybe negative, is it negative 3? Can I take negative 3? Yes. So I'll say negative 3 with a cos of x into cos of x. And then this will be positive 1. And this is equal to 0. So that when we multiply in this one, we'll get a negative cos, right? And then at this point, we can now be able to take another common factor, right? So if you see or if you check, you'll be able to see that this portion here, right? This portion here is forming another common factor for this, right? So let me start by writing maybe this common factor by just taking it out. Cos x plus 1, right? This is my common factor into the remaining equation, sine x, and then minus what? Minus 3 the cos x, right, is equals to 0. And then with that, it means that now I can be able to say that, what was that? I can be able to say cos x is equals to negative 1, right? And then, or the sine of x is equals to 3 cos x. And we are not looking for something like this. So when we simplify these, we can divide both sides by cos, just to be, just to have the 3 there. So I'm going to say cos x and then cos x. And this will delete or eliminate that. And then I'll be left with sine and cos will give us a tan. Be left with tan x, which is equals to 3. All right. So this is our solution. Remember the sec, remember the cot, and other ones. If you decide to divide by sine, you'll end up with cos x all over sine. So you'll go to these ones, but the best one is to eliminate these by cos x so that you can end up with tan x, right? So at the end of the day, we are like done with our solving for this particular equation, and you can just go and say maybe x is equal to 180 plus k dot 360, if you do remember that point, right? So let me do something. I don't know if I do have a calculator that you can actually use at this point, right? So you can go and say that shift tan 3, and then you get 71 dot comma 56, and with this, let me just do this, right? Remember what you got, so I'm just going to write it down, right? So that was what, that was the tan x, which is equals to 3, and x as an angle, remember, can be something like tan, 3, and then that gave us 71 comma something, let me check, comma 56 and 5. If we round this to 2 decimal, this will be 57, and then I'm going to write our 57 degrees, and then this will be plus k, the positive elements of integers as given, and also you can use k element of z. Okay, so I hope that this will help you to understand this. Let me just do this as well, but I feel like you do understand by now that you can also go and say the cos of -1 will give you 180, and then you repeat the process to say x is equal to 180 plus k dot 360 and so forth. Okay, I hope that you do understand that, although I was trying to omit it, or I've omitted it in the previous questions. Okay, thanks.